We're going to begin this section of 3.2 where I left off on the last one. And I have to apologize. I hung up my computer, but I think we're really okay. I think it just got tired of doing videos. All right. So here we had this problem, and the problem was 161 heights of males was our sample. And they gave us the low value, 158 centimeters, and a high, the highest value, 194 and 9/10 centimeters. But they wanted the standard deviation. Now, we didn't have the data, so they wanted us to use the rule of thumb. And that was the max x minus the min x divided by 4. So I have 194 and 9/10, subtract 158 for the numerator divided by 4. And we got this value. Okay, now we discussed it in the last one. Then they said compare. And we said, oh, we take the difference. And what we did, we got less than 1 centimeter. I forgot to put that on there. Very close to what we're going to compare it to. So if we compare it to the 10 and 600ths, we're only 83 hundredths difference between the rule of thumb and the expected, the actual standard deviation of the actual data. And I am going to write the approximation is, I wrote the answer in, is accurate because the error of the range of rule of thumb, thumb's approximation is less than 1 7/10 centimeters, because we know that 83 hundredths is less than 1 7/10 centimeters. So because it is so small, the rule of thumb and the data that was collected was very close to each other. So we're going to move on to the brain volume. Excuse me. The brain volumes in centimeters cubed, because it is volume, of 20 brains. So our N is 20. We have 20 brains that they're looking at. Have a mean, and this is a sample, so it's an X bar, of 1077 and 1/10 centimeters cubed. And a standard deviation, so that's a small s because it's a sample, of 123 and 6/10 centimeters cubed. They said use the given standard deviation and the range rule of thumb to identify the limits. We want limits that are significantly low and significantly high. And that means 2 standard deviations around the mean. Small math. So let's do this small math and get comfortable with what we want. So we understand for low that, excuse me, for the significantly low, we use X bar minus twice S. And that's because we're moving the information from the mean to standard deviations here. So if this is X bar, we want this value here, which is 2 standard deviations away. It's the negative 2s. So I'm going to enter what I have, my 10, 7, 7, and 1/10 minus twice the 123.6 centimeters cubed. And of course, we're going to use our calculator, which I forgot to turn on. Take me a second. So I'm going to do a second quit to get on my home screen. I'm going to clear it. I was working on some data, I thought, 1077 and 1/10 minus 2 times that 123.6. Again, I double check in, garbage out, and I get, oops, sorry, I get the 829 and 9/10 centimeters cubed. That's the position of this negative 2s from the mean. And so I'm going to put right here 829 and 9/10 centimeters cubed or lower is significantly low. Now we're going to do the high. Well, the high is easy because it's x bar plus 2s. And that means I'm going to have the 1077 and 1/10 minus 2 plus 1 2 times 1 2 3 and 6/10. So let's do this math and see what we get. So I don't know if I've told you on the calculator, if the sign is different, you do a second entry, it'll paste it, and then you can change the operator to a plus and save you some work. So this value is 1, 3, 2, 4, and 3/10 centimeters cubed. So that's the significantly high. On the right side is 1, 2. This one here, which is a plus 2 standard deviations. And I'll enter that number, 1, 3, 2, 4, and 3/10 centimeters cubed, or higher, is significantly high. Is 100, now we have a question, is 1,364 and 3/10 centimeters cubed significantly high? Well, they're asking us, well, we know what our high is. So we compare the listed uh, value to significantly high value. So we have right here is 1, 3, 6, 4, and 3/10, and we're comparing it to 1, 3, 2, 4, and 3/10. Well, this guy is greater than that. That means that 1, 3, 6, 4, and 3/10 centimeters cubed is significantly high. Because it is greater than 13, 24, and 3/10 centimeter cube brain size. So it is a larger brain volume. Okay, very good. Now here's a little recap question, and it's important that we know the symbols. Symbols in mathematics determine type, kind, and operations. So in statistics, it is important to distinguish between a sample and a population. Statistics are done mainly on samples because we couldn't possibly control everything um, in the study. So we take samples. All right. Identify the symbols used in each of the following. A sample standard deviation is the lowercase s. The sample standard variance is the square of the sample standard deviation. All right. Well, the population standard deviation is the delta sign, and therefore the standard variance is the delta squared. So these are the symbols that distinguish samples of standard deviation and on population. And those can give you a heads up of what the study is using. So now let's do our calculator notes. And for this calculator notes, we're looking at our 5-number summary again. And our 5-number summary is very important. So I mentioned it again. Now we've done it all along. So now what we want is to find the standard, the range, the variance, and the standard deviation. So we'll be focusing on the sample standard deviation, and of course, the min and the max to find the range, and then to find the variance of the data. We'll use at least 4 decimal places of the standard deviation. And that way when you round, it'll match the homework. I don't want you to do any extra work. This is just making sure you put it on your paper and you'll get it. All right. So we understand several things. We understand that range is high data minus low to give us a span. We know that standard deviation is S for sample and theta, S of X, and theta if it's a population. All right. And then we've already discussed this. We'll square 4 decimal places and we'll be accurate. So here we go. And we can do this. We've done the entering data quite often, so it's supposed to be pretty well easier for you to handle now. So let's look at our problem. Below are the jersey numbers of 11 players. So we know we have N is 11. Randomly selected, so we know that it's a random sample, from a football team. Find the range, the variance, and the standard deviation. All right. So to do that, we're going to take some steps. We're going to enter the data. Here we go. So I'm going to bring down my calculator and place it so everybody can see what I'm doing. And again, you can pause or look back at some old notes if I didn't give you enough time to do whatever you needed to do to figure out where I'm at. So I'm going to clear my home screen. I'm going to go to the Stat key. I want edit because that's the window I want. I've got data in it, so I'm going to do a up arrow, clear inner. We have 11 data, so the next clear one is going to be 12. So we're going to do 34, 71, 89, 18, 54, 80, 21, 32, 67, 63, and 47. So I should be at 12. I am. I'm going to double verify that I didn't omit any numbers. Now, I've got an 18. That looks very low, but okay. So now I have it. Okay. So I'm going to do a second quit to get on my home screen. And I need the 5-number summary. So we're going to give it a command. Here we go. So let's give it a command. I'm going to go to Stat, arrow over to Calc, and then I'm going to choose number 1 by enter. And then I'll enter, enter, enter. So you do 3 times enter, and you'll see this. So they want the range. So I need the high minus the low. Well, the min-x is 18, and the max is 89. Okay, so I'm going to arrow up. I need the standard deviation. So my standard deviation, we're going to do two decimal places. So the standard deviation is the SX, and we want 2 decimal places, so I'm going to say it's 24 and, oh, actually, we want 1, 2, 24.2. And then we want the variance, which is the S of X squared. And we're going to do 4 decimals. So on this one, we're doing 23.0468. Okay, and square it so we can get the answer we need. All right, so here we go. So I'm going to clear my home screen and do some math. 89 minus the 18. The span is 71 numbers. Okay, we got the standard deviation. We need to figure out the variance. So I'm going to enter the 23 decimals, 0.68. Sorry. And I'm going to hit the X squared, which is the 1, 2, 3, 4, 5th key, first, of 5th row, first key. And I'll enter. And I get 5, 3, 1, decimal 1, 5, 4, blah, blah, blah. And we'll do 1 decimal place. Do I have that transposed? Let me look. I might have. Let me do that. It is 2, 4, 6, 8. I sure did. I did have it correct. 2. Oh, I put a 3. God, what's wrong with me? I said, God, that's kind of not what I needed. All right, I'm sorry. I said 2, 4, decimal 0. Okay, let's do it again. Your instructor strikes again. 2, 4, decimal 0, 4, 6, 8, x squared. There we go. I thought that's really low. Okay, let's try this. And it made a big difference, didn't it? So what this gives me is 5, 7, 8, 2, 4, 8, blah, blah, blah. We'll want one decimal place. 5, 7, 8, and 3/10. So I have it. Okay. Hopefully I didn't make any entry errors. Evaluate the result. Well, what do we want to evaluate? Okay, now let's look at this. The range is 71. The standard deviation is 24. It's a big gap. And the variance is this value. So what we have is common sense. Using, sorry, not doing, using the athlete's jersey numbers is, well, actually is jersey numbers. Let me do some, as data, knowing the numbers are nominal. That means name, right? Remember? It's meaningless. There's no context to the numbers. They're just jerseys with numbers that refer to a name. So even if we did math, it's irrelevant. It doesn't have a status. But we do check to see if there's a rhyme or reason. And everybody always studies everything just for the sake of seeing if there is a relationship of how the guys choose their numbers. Excuse me. Okay, we're going to do another one. Listed below are the amounts in dollars it costs for a marriage proposal package at different baseball stadiums. Find the range. Hold on. So we're looking at the cost of these things and seeing what choices some of these people who want this to occur for their memory, um, excuse me, we want to find the range, the variance, and standard deviation. So let's do this. We have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, it appears. Find them, okay. Include appropriate units in the result. Are there outliers? And are likely to have an effect on the measure of variation. And so we're going to do that. And we're going to first get our calculator. Here we go. Somehow it closed it. On any given day, your instructor is always interesting. Here we go. There we go. I'm going to clear my screen. I'm going to go to Stats, Edit. I have data, so up arrow, clear enter. And I'm going to enter the data carefully. So here we go. Take a picture if you like with your cell phone so that you can have vision on entering in your own calculator. You should be following along, otherwise it's pretty meaningless. My throat is dry, so I'm going to talk less for a little bit. My lozenge works. Okay, now I'm going to double check. These numbers are fluctuating a lot. They're very, very small all the way to very large. So I'm going to double check. 3,000, 1,500, 450, 350, 255, 219, 190, 150, 95 twice, 70, 65, 50, 50 twice, and 37. Good. So now that I've done that, our second step is to calculate a 5-number summary. To find some values. Here we go. So at this juncture, I double checked my data, stat, calc, one variable, enter, 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 and I get some values. So we know that the range is max x minus min x. So let's find those values. We know the minimum is 37. We looked at that and we knew it. And the maximum is 3,000 because the data is in order. Okay, so we want the standard deviation. It's a sample, so we want S of x. And we want 1 decimal place because we're just doing data for the procedural aspect of this problem. And the standard deviation for the sample is 7, 9, 7, and 1, 9. So we're going to make it a 2. And we need the denomination. So this is going to be dollars. Okay? It's going to be dollars. So money is in 2 decimal places. So then we need the variance. Now, the variance is going to be the square of the standard deviation to 4 decimals. 797.1920 squared. All right, so now I'm going to do my range, and I'm going to have the 3,000 minus the 37, the 29.63, and it's dollars. So the range is $2,963. That's pretty much a span. And you saw that the standard deviation is large as well. So the variance is going to be, I enter the number 797.2, I'm sorry, 1920, okay? 1920, and square it. This is going to be huge. All right, look at this number. Oh my goodness. 63551500849. Okay, so what we're going to do is do one decimal place, and that will be 6355151. And we're going to add the 0. Okay. So that's ridiculous, isn't it? Okay. Well, this problem is a little absurd because if we do 37 and then 3,000, that is a gap. So are there any outliers? If so, how much of an effect on the measured variance? Okay, well, it's obvious that from 400 to 1,500 and 3,000 is ridiculous. So we're going to have two outliers. The 37 to 50 does not exceed this gap. So it looks like the 37 does look like an outlier, but it's not. This is ridiculous, though. So yeah, yes are two outliers. There are the 1,500 and the 3,000. Okay, so now we're going to address the problem. These largest amounts are obvious uh, because they stand out and affect the data. I shouldn't say to, on the computations, the standard deviation, range, and of course, variance. Without them, this is really big. And if we used it with the data average, we go below, we go into the negative numbers, negative money on the bell curve. So it's just bad data. The outliers just moved everything to craziness. All right, we're going into examples of comparison of coefficients of variation for each of the two samples. So now we have two sets of data. and calculating a coefficient is a number, coefficient of variation, of change, for the non-negative samples. Okay, so we're going to get this number, this relationship, and it is a ratio. Ratio means fraction. And we know the ratio is either S over the mean or the delta over the mu for population. And each one we multiply by 100 to get a percent. All right. Now we use these coefficients to gauge the closeness or effect of the variance of the data. And we're always going to compare it to the 5%. So let's make a notation of that. Let me write it down so everybody can understand. I didn't type it in. The coefficient of variance for each asset are measured by a 5% comparison. I'll say comparison. So if the coefficient, and I'm going to use CV, the coefficient of variance, is less than 5%, if the data sets are 5%, and if they're less than 5%, the variance is of low significance. If the coefficient variable is greater than 5%, then it is the variance is significantly high. Okay, so the 5% shows that, yes, there is a distinct proof that something is valid in the coefficient. So let's look at these two data. And I'm going to introduce using line 1 and line 2. And I'll talk you through it and I'll make notes as we go. So let's read what we're studying here to analyze. Listed below are pulse rates beats per minute from samples of adult males and females. Does there appear to be a difference? That's our question. So that's where the measurement of the CV is going to happen. Find the coefficient of variance, so that's our CV, for each of the samples, and then compare the variation. So our first step is to enter the data. I'm running long, I'm sorry. After this one, I'll stop the video. We have just a tad more, but I will stop it so that no one gets behind or bored. It's just a lot of technology on this one, and I apologize, but I got to get it done. Okay, here we go. We're going to go to our stats, our edit. Okay, we're going to up arrow, clear enter, and make sure that line 2 is clear. We're going to make line 1 the male. And so I'm going to enter the data, and you do so as well. Oh, I must have hit a negative. Oh, I did. Sorry. Okay, 536453. Okay, I got it. Okay, and I have 16. I'm going to double check my entries. 65, 56, 97, 64, 61, 70, 83, 53, 64, 53, 71, 69, 63, 68, and 86. Good. I'm on a side arrow. Let me go back. I have done line 1. I use side arrow to get to line 2. And I will begin doing the females. 65, 80. Okay, so I know I have the right entry of quantity. I'm going to double check now to make sure I did not omit something. 80, 82, 86, 68, 93, yep, 93, 88, 87, 84, 87, 85, 76, 72, 79, 80, and 65. Great. So I'm going to go on my home screen, and we want to find the two things we need, which this is a sample, so we need for the males, we need the S, and we need the X bar for the data, because it's a sample, because that's what our coefficient is, S over X bar. Okay, Oh, well, I'm not going to do the formula, so I'll just put the X bar. Sorry about that. All right, here we go. So this one was on line 1. So what we're going to do is command, which is going to be our stat, arrow over to calc. Now we're going to choose one variable stat, and enter, enter. But you get that. Enter 3 times. All right. And because it is, we're going to use default of line 1. So here we go. Stat, we're going to go to calc, one variable. It's line 1. So 1, enter, enter, enter. Okay. So for the standard deviation, we want to use, I think we want to use only 1. For the X bar and the standard deviation is 2. The standard deviation is 2. So let's do the S. So that is 12.283 ... So we're going to say 12.28. The X bar we have 1, so that one was easy, 68 2/10. So now we're going to do the females. And they're in line 2. So we want the S and the X bar. So let's do that. So we're going to go to stat, calc, one variable, but this time we're going to do a second number 2, because that'll be line 2, second L2. So that's what we're going to do to tell the calculator we want the female list, second 2. And you can see that it's entered there. Now we're going to enter 3 times and get what we need. So our S is 7.802, whatever. Okay. And we want 2. All right. And our average, or our mean, is 80 8/10. All right. So we want to, now that we've done all that work, we want to, this is step 1. Now we want to calculate our coefficient. So now we want our coefficient of variation. And that means this is number 1 step, number 2 step. This means that we're going to find the percents. And they are the S divided by X bar times 100. And then we're going to add the percent. So let's look at that. So for the males, we have 12 2/28 divided by the 68 2/10. For the females, we're going to have a smaller 7 80/100 divided by this 80 8/10. All right. So let's see what happens here when we do this math. Here we go. Going to use our calculator. I'm going to clear my screen, and I'm going to enter what I have. I'm going to have it in times 100 to get the percent. I left that off. I'm going to put 12.28 divided by the 68 and 2/10 times that 100. When I do that, I get 18%. I'm going to say 18%. Okay, now I'm going to do the second one. 7 and 8/10 divided by the 80 and 8/10. And I get, oh, I forgot the 100, sorry, times the 100. Sorry about that. I'm going to have 9, and I'll do 1.7%. All right. Now, what do we notice? Just by eyeballing, uh, the mean for women are larger, and the standard deviations are less for women, meaning that there is less of a change. That it's high and it's a small increments moving, where in the men, it is a larger grouping. So now we're going to compare it. So what happens when we compare this thing? All right. We can say coefficients of variation. We're going to compare them. We understand that 18% for males is larger than uh, it's larger than females. 9 7/10% females. So we can say then that the coefficient, so we're going to take the difference, gives us, and we'll do the math on the calculator because it'll just work better. 8 3/10. All right. So let's see what we have. Now we're going to take this number and compare it with the 5%. 8.3%, because that's going to be extremely high, right? Is larger than the 5%. So significant, so it is significantly high, meaning we have to pay attention. So it is really enough variance to say, okay, the male pulse rate very significantly high, well, I should say more, very more, oh, I need to use more on that one, than the female rates. Because significantly high and significantly low are the ones we're looking at. Okay, that was excellent. Now we're at, I know I better stop. I'm going to stop right here, and I will talk about the bell curve on the very last one. You understand that I had that, the computer tie up on the second part, and I'm sorry about that, but we'll continue on. Thank you for listening.